Imagine standing in the middle of one of the hottest deserts on Earth. For hundreds of miles in every direction, there is almost no rain. The Sahara Desert receives less than 25 millimeters, or about 1 inch, of rainfall each year in many places. Yet cutting through this vast sea of sand is one of the greatest rivers humanity has ever known. The Nile. A river that has sustained civilizations for thousands of years. A river that transformed barren desert into fertile farmland. A river that made ancient Egypt possible. But here's the mystery. If the Nile flows through one of the driest places on Earth, why hasn't it dried up? How has this river continued flowing? Not for centuries, but for millions of years. Has it always existed? Where does all that water actually come from? And could the Nile someday disappear? Today we're uncovering one of the greatest natural mysteries on our planet. This is the incredible story of why the Nile River refuses to die. Before answering the mystery, let's understand what makes the Nile so extraordinary. Stretching approximately 6,650 kilometers, or 4,132 miles, the Nile is one of the longest rivers in the world. Depending on how its source is measured, it is often considered either the world's longest river or second only to the Amazon River. The Nile flows through or drains parts of 11 African countries: Tanzania, Uganda, Rwanda, Burundi, Democratic Republic of the Congo, Kenya, Ethiopia, Eritrea, South Sudan, Sudan, Egypt. Millions of people depend on its waters every single day. In Egypt alone, roughly 95% of the country's population lives within a few miles of the Nile, because nearly all the rest of the country is desert. Without the Nile, modern Egypt as we know it simply would not exist. But here's the astonishing part. Egypt receives very little rainfall. In Cairo, the average annual rainfall is only around 25 millimeters. Some years, parts of southern Egypt receive almost no measurable rain at all. Yet the Nile flows every day, every month, every year, for millions of years. How? Most people assume rivers are fed by rain that falls nearby. That's true for many rivers, but not the Nile. The water flowing through Egypt today did not fall as rain in Egypt. Instead, much of it began its journey thousands of kilometers to the south, in regions that receive abundant rainfall. This is the first secret behind the Nile's survival. The Nile is not a desert river. It is a tropical river traveling through a desert. That distinction changes everything. Many people think of the Nile as one continuous river. In reality, the Nile is formed by two major rivers that meet in Sudan. These are the White Nile and the Blue Nile. Each has a completely different origin. Each contributes water in different ways, and together they create one of Earth's most reliable river systems. Let's begin with the White Nile. The White Nile is often considered the longer of the two branches. Its waters originate in the Great Lakes region of East Africa. The largest contributor is Lake Victoria, Africa's largest lake by surface area. Lake Victoria is enormous. It covers nearly 69,000 square kilometers. That's larger than many countries. But where does Lake Victoria get its water? Rain. Lots of it. The regions surrounding Lake Victoria experience tropical climates. Many areas receive 1,000 to more than 2,000 millimeters of rainfall every year. Compare that with Egypt's 25 millimeters. That's up to 80 times more rain. Because rainfall occurs throughout much of the year, the lake acts like a giant natural reservoir. Instead of flooding all at once, it slowly releases water into the White Nile. This steady release keeps the river flowing even during dry seasons. In other words, Lake Victoria works like Earth's natural water storage tank. Imagine pouring a bucket of water onto concrete. The water rushes away almost immediately. Now imagine pouring that same bucket onto a giant sponge. The sponge absorbs the water, then slowly releases it over time. That's essentially what East Africa's lakes and wetlands do. Not just Lake Victoria, the White Nile also passes through vast wetlands, including the famous Sud in South Sudan. Covering tens of thousands of square kilometers depending on seasonal conditions, the Sud is one of the largest wetlands in the world. These wetlands store enormous quantities of water. Some evaporates, some nourishes wildlife, and much of it continues its slow journey northward. This natural buffering system helps stabilize the river's flow. Even when rainfall varies, the White Nile continues moving. Day after day, year after year, century after century. But despite its importance, the White Nile is only half the story. Because farther east, another river delivers something even more powerful, the Blue Nile. And without it, ancient Egypt may never have existed. While the White Nile provides the river with a dependable, year-round flow, there is another branch that completely transforms the Nile every single year. It begins not in a desert, not in a jungle, but high above sea level in the mountains of Ethiopia. Welcome to the Ethiopian Highlands, sometimes called the Water Tower of Northeast Africa. These mountains hold the second great secret behind the Nile's remarkable endurance. The Blue Nile begins at Lake Tana, Ethiopia's largest lake, located at an elevation of about 1,800 meters, 5,900 feet, above sea level. At first glance, Lake Tana appears peaceful. But every summer, something extraordinary happens. Warm, moisture-filled air from the Indian Ocean moves inland. As this air is forced upward by Ethiopia's mountains, it cools. Cooler air cannot hold as much moisture. The result? Massive seasonal rainfall. This process is known as orographic rainfall, and it is one of the most important reasons the Nile has survived for so long. Some parts of the Ethiopian highlands receive more than 2,000 millimeters, nearly 80 inches, of rain every year. That water rushes downhill into rivers, streams, and eventually into the Blue Nile. Every year between June and September, East Africa experiences powerful seasonal rains. These rains are influenced by the movement of the Intertropical Convergence Zone, ITCZ, a belt of low pressure near the equator where warm, moist air rises and produces heavy rainfall. As the ITCZ shifts northward during the Northern Hemisphere summer, it brings intense rains to Ethiopia. The Blue Nile swells dramatically. This is why, throughout history, the Nile rose during the summer months, even though Egypt itself remained almost completely dry. Imagine living in ancient Egypt. For months there is almost no rain. The sky remains clear. Then suddenly, the river begins rising, not because of local weather, but because it had rained hundreds of miles away. To ancient Egyptians, this annual flood seemed almost magical. The Greek historian Herodotus, writing more than 2,400 years ago, famously called Egypt the gift of the Nile. It wasn't an exaggeration. Every summer the Blue Nile carried enormous amounts of water, and something just as valuable: rich, dark sediment. As floodwaters spread across the Nile Valley, they deposited fertile silt carried from Ethiopia's volcanic highlands. When the waters receded, farmers planted crops in nutrient-rich soil. No chemical fertilizers, no irrigation pumps. Nature had already done the work. This annual cycle supported wheat, barley, flax, vegetables, fruits, and papyrus. It fed millions of people and allowed one of the world's greatest civilizations to flourish. Without those seasonal floods, ancient Egypt may never have become a powerful kingdom. This surprises many people. Although the White Nile is generally the longer branch and provides a steadier base flow throughout the year, the Blue Nile supplies most of the water that reaches Egypt during the rainy season. On average, the Blue Nile contributes about 55 to 60% of the Nile's annual flow at Khartoum. The White Nile contributes roughly 25 to 30%, helping sustain flow during the dry season. Additional water comes from tributaries such as the Atbara River, which also rises in Ethiopia and contributes significantly during the rainy months. These percentages vary from year to year depending on rainfall, but together they explain why the Nile is so resilient. The White Nile provides stability. The Blue Nile provides seasonal power. Together they create a river system unlike almost any other on Earth. The White Nile and Blue Nile meet in Khartoum, the capital of Sudan. Here, two rivers with different colors, temperatures, and sediment loads merge. From this point northward, they form the Nile River that flows through Sudan and Egypt toward the Mediterranean Sea. Every drop of water passing the pyramids near Giza has traveled an incredible journey. Some began months earlier in the tropical rains around Lake Victoria. Others fell as rain on Ethiopia's mountains just weeks before. Different origins, different climates, one river. Many rivers depend almost entirely on recent rainfall. When the rains stop, the rivers shrink dramatically. Some disappear altogether. The Nile behaves differently because it has multiple natural storage systems working together. First, the immense lakes of East Africa store water and release it gradually. Second, wetlands like the Sud act as natural reservoirs, slowing the movement of water. Third, groundwater in parts of the basin can sustain river flow during drier periods. And finally, because rainfall occurs in different regions at different times of the year, the Nile benefits from a diversity of water sources rather than relying on a single rainy season. Nature has built redundancy into the system. If one area receives less rainfall in a given year, another region may still contribute enough water to keep the river flowing. To understand why the Nile has persisted for so long, we need to step back and look at the bigger picture. The Nile is part of Earth's global water cycle. Water evaporates from oceans, lakes, rivers, and plants. It rises into the atmosphere. It forms clouds. Those clouds are carried by winds across continents. Eventually, they release rain over East Africa. That rain becomes streams. The streams become rivers. The rivers become the Nile. Finally, the Nile empties into the Mediterranean Sea, where the cycle begins again. This process has operated for millions of years. As long as Earth's climate continues to support rainfall in the Nile basin, the river can continue to flow. But if the climate changes significantly, the story becomes far more complicated. Think about everything the Nile has witnessed. Long before the first pyramid was built, the Nile was already flowing. It flowed while mammoths still walked parts of the earth. It flowed before written language, before iron tools, before the wheel reached Egypt. It witnessed the rise and fall of pharaohs, Greek rulers, Roman emperors, Arab caliphates, Ottoman governors, colonial powers, and modern nations. Empires have disappeared, kingdoms have collapsed, borders have changed. But the Nile kept flowing. The question is, how has it survived not just thousands of years, but millions? The answer lies beneath the Earth's surface, in powerful geological forces that shaped Africa itself. The geological secret. Is the Nile really millions of years old? So far, we've discovered where the Nile gets its water. We've seen how tropical rainfall, massive lakes, and the Ethiopian Highlands work together to keep this legendary river flowing. But there's an even bigger question. Has the Nile always flowed this way? Or has it changed over millions of years? For decades, geologists debated the true age of the Nile. Some believed the modern Nile was relatively young, forming only a few million years ago. Others argued that an ancient predecessor existed much earlier, but followed a different route. Today, advances in satellite mapping, sediment analysis, seismic imaging, and computer modeling have transformed our understanding. The answer is more fascinating than anyone imagined. If you could travel back 100 million years, Africa would look almost unrecognizable. The climate was different, sea levels were different, mountain ranges were different. Many of today's rivers simply did not exist. Over tens of millions of years, the African continent slowly changed through the movement of tectonic plates. These plates move only a few centimeters each year. That's about as fast as your fingernails grow. But over millions of years, even tiny movements can reshape entire continents. Mountains rise, valleys sink, lakes form, and rivers are forced to find new paths. One of the most dramatic geological features on Earth is the East African Rift System. Stretching thousands of kilometers from the Red Sea toward Mozambique, this enormous system of faults has been slowly pulling Eastern Africa apart for roughly the last 25 to 30 million years. As the land shifted, huge basins formed. Some filled with water, others became lakes. Among them were many of the lakes that now feed the White Nile, including the region surrounding Lake Victoria and neighboring lake systems. Without this geological activity, the Nile basin would look completely different today. The landscape itself helped create the conditions necessary for one of the world's greatest river systems. While the Rift Valley shaped Eastern Africa, another geological event occurred farther north. Powerful volcanic activity lifted much of Ethiopia into a vast plateau. Over millions of years, lava flows built the Ethiopian Highlands into one of Africa's highest regions. Many peaks exceed 3,000 meters, and several rise above 4,000 meters. These mountains perform a crucial job. When moisture-laden air arrives from the Indian Ocean, it is forced upward. As it rises, it cools. Clouds form. Heavy rains fall. Without these high mountains, much of that moisture might continue moving inland without producing nearly as much rainfall. In other words, the mountains themselves help create the rain that feeds the Blue Nile. Now comes one of the biggest surprises. Today, the Sahara is the world's largest hot desert, but it hasn't always been dry. Between roughly 14,500 and 5,000 years ago, during a period scientists call the African Humid Period, much of the Sahara looked dramatically different. Satellite imagery has revealed the remnants of ancient rivers buried beneath the sand. There were enormous lakes, grassland stretched across regions that are now barren. Hippos, crocodiles, elephants, giraffes, and other wildlife thrived there. People hunted, fished, and built settlements in places that are now among the driest on Earth. Climate shifts caused by subtle changes in Earth's orbit altered rainfall patterns. Gradually, the monsoon retreated southward. The lush landscape dried. The Sahara Desert expanded. Many rivers vanished forever. But not the Nile. Why? Because unlike those ancient rivers, the Nile's main water sources remained far to the south in wetter climates. Even as northern Africa became increasingly arid, rainfall continued in equatorial East Africa and the Ethiopian Highlands. The Nile continued carrying that distant water through an increasingly dry landscape. Scientists now believe the Nile has changed course multiple times throughout Earth's history. Ancient river systems merged. Others disappeared. Some flowed in different directions before being captured by newer river channels, a process geologists call river capture. Imagine pouring water down a hillside. If you dig a deeper trench nearby, eventually the water abandons its old path and begins flowing into the new one. Nature works the same way, although over much longer timescales. As landscapes rose and eroded, the Nile Basin gradually evolved into the river system we recognize today. In 2019, researchers published evidence suggesting that the Nile's northward course may have been maintained for around 30 million years, much longer than many scientists had previously believed. Their research proposed that deep mantle processes beneath Ethiopia helped keep the land elevated, preserving the river's overall direction toward the Mediterranean. Not every detail is settled, and scientists continue to study the Nile's complex history. However, there is growing evidence that while individual channels and tributaries changed over time, the broader northward drainage system has ancient geological roots. This means the Nile is not simply an old river. It is the product of millions of years of continuous geological evolution. Throughout Earth's history, countless rivers have dried up. Some were blocked by volcanic eruptions, others were diverted by glaciers, some vanished because regional climates became too dry. The Nile avoided complete collapse because it possesses several extraordinary advantages. First, it draws water from multiple climate zones. Second, its drainage basin covers more than 3 million square kilometers, making it one of the largest river basins in the world. Third, its sources lie in regions that continue receiving substantial rainfall, even when northern Africa experiences severe drought. Finally, geological uplift helped maintain the elevation differences needed for water to keep flowing downhill towards the Mediterranean. Together, these factors gave the Nile remarkable resilience. It's a question scientists continue to study. Under today's climate, a complete drying of the Nile is considered highly unlikely. However, that doesn't mean the river cannot change. Extended droughts, changing rainfall patterns linked to climate change, growing water demand, and the construction of dams and reservoirs can all affect how much water reaches downstream communities. The Nile has survived immense natural changes. Its greatest challenges in the future may come from both climate variability and the increasing demand for fresh water across the basin. For millions of years, continents shifted, mountains rose, deserts expanded, ancient lakes appeared and disappeared. Ice ages came and went. Human civilizations rose and fell. Yet the Nile continued flowing north, not because it escaped Earth's changes, but because it adapted to them. Its survival is the result of geography, climate, geology, and the global water cycle working together over immense spans of time. And that is what makes the Nile one of the greatest natural wonders on our planet. For millions of years, the Nile has overcome incredible challenges. It survived shifting continents. It endured dramatic climate changes. It continued flowing as the Sahara transformed from green grasslands into the largest hot desert on Earth. But today, the Nile faces a new challenge, not from nature alone, from humanity. Today, the Nile Basin is home to more than 300 million people across 11 countries, and that number is expected to continue growing in the coming decades. Every day, the river provides drinking water, irrigation for agriculture, hydroelectric power, transportation, fishing, industrial water supplies, livelihoods for millions of families. In Egypt, the Nile provides the vast majority of the country's freshwater resources. Agriculture, cities, and industries all depend heavily on its flow. Sudan also relies extensively on the river for farming and electricity. Farther south, countries such as Uganda, South Sudan, and Ethiopia depend on the Nile system for food production, economic development, and growing populations. The Nile is no longer just an ancient river. It is one of the world's most important shared water resources. One of the greatest engineering projects ever built on the Nile is the Aswan High Dam, completed in 1970 in southern Egypt. Before the dam, the Nile flooded every summer. Those floods brought fertile sediment to Egyptian farms, but they could also be unpredictable. Some years the floods were too small, leading to poor harvests. Other years they were so large that villages and crops were damaged. The Aswan High Dam changed that. Behind the dam lies Lake Nasser, one of the world's largest artificial reservoirs. Today the dam provides several major benefits: reliable hydroelectric power, flood control water storage during droughts, improved irrigation throughout the year. But every solution creates new challenges. Because the dam traps much of the fertile sediment that once flowed downstream, farmers increasingly rely on commercial fertilizers. The reduced sediment reaching the Mediterranean has also contributed to increased coastal erosion in parts of Egypt's Nile Delta. The Nile continues flowing, but humans have changed how it behaves. Important River, a project meant to Another major development is the Grand Ethiopian Renaissance Dam, commonly known as the GERD. Built on the Blue Nile in Ethiopia, the dam is one of Africa's largest hydroelectric projects. Once fully operational, it is designed to generate more than 5,000 megawatts of electricity, helping expand access to power in Ethiopia and potentially neighboring countries. Ethiopia views the project as essential for economic development. However, because the Blue Nile supplies a large share of the water reaching Sudan and Egypt, the project has raised concerns downstream. The main issue is not whether the dam permanently stops the Nile. It does not. Instead, discussions have focused on how quickly the reservoir is filled, how water is managed during prolonged droughts, how countries cooperate during periods of low rainfall. Negotiations among Ethiopia, Egypt, and Sudan have continued for years, reflecting how important shared water management has become. The Nile is a river that connects nations. Its future depends not only on rainfall, but also on cooperation. One of the biggest questions is whether climate change could cause the Nile to dry up. The answer is more complex than a simple yes or no. climate models suggest that rainfall patterns across the Nile basin may become more variable. Some regions could experience heavier rainfall. Others may face longer dry periods. Scientists are still working to understand exactly how the basin will respond, because different climate models produce different regional projections. What is widely agreed upon is this: extreme weather events, including droughts and intense rainfall, are likely to become more common in many parts of the world. That means water management will become even more important. The challenge may not be that the Nile disappears. The challenge may be managing greater variability while serving a rapidly growing population. This question has fascinated historians, scientists, and travelers for centuries. Based on current scientific understanding, a complete drying of the Nile under today's climate conditions is considered extremely unlikely. Why? Because the river does not depend on a single source. It is supported by tropical rainfall in East Africa, seasonal rains in the Ethiopian Highlands, large lakes that naturally store water, wetlands that regulate river flow, a vast drainage basin spanning multiple climate zones. For the Nile to disappear entirely, multiple major components of this system would need to fail simultaneously over an extended period. That is not considered a likely scenario based on current evidence. However, regional droughts, reduced flows during certain years, and increased competition for water remain real concerns. The Nile teaches us something remarkable about our planet. No single force keeps it alive. Not one lake, not one mountain, not one rainy season. Instead, it survives because countless natural systems work together. The atmosphere transports moisture, mountains create rainfall, lakes store water, wetlands regulate flow, gravity carries rivers northward, and the global water cycle repeats the process over and over again. The Nile is not just a river. It is one of Earth's greatest examples of interconnected natural systems. For thousands of years, people believed the Nile was a mystery beyond explanation. Ancient civilizations worshipped it. Explorers searched for its source. Empires fought to control it. Today, science has revealed many of its secrets. We now know that the Nile survives because of tropical rains, seasonal monsoons, geological forces, vast lakes, wetlands, and a water cycle that has operated for millions of years. Yet despite everything we've learned, the Nile still inspires wonder. Every drop flowing past Luxor, every current passing beneath Cairo's bridges, every wave reaching the Mediterranean, is part of a journey that began hundreds or even thousands of miles away. It is a journey powered by nature on a continental scale, a reminder that some of Earth's greatest miracles are not miracles at all. They are the result of extraordinary natural processes working in perfect balance. For millions of years, the Nile has carried life across one of the harshest landscapes on Earth. And if humanity protects this remarkable river, it may continue doing so for countless generations to come. If you enjoyed this documentary and want more fascinating stories about Africa's geography, history, wildlife, science, and natural wonders, be sure to like this video, subscribe to the channel, and turn on notifications so you never miss our next documentary. Question of the day. If you could visit any place along the Nile, from the source near East Africa, the Ethiopian Highlands, the ancient temples of Luxor, or the pyramids near Cairo, which would you choose and why? Let us know in the comments below. Thanks for watching, and we'll see you in the next adventure.